To go ahead and recap of the previous video, we are on section 3.1, derivatives of polynomial and exponential functions. So as we get to number 21, and this is again the limit definition of the first derivative, you should recognize that a, in this case, is 5. The number that we need to find is 5. So a is an x value, so we can replace in this the 5 with an x and write down that f of x equals e to the x. We're going to find the derivative first, and when we take the derivative of e to the x, it's a rewrite and then natural log of the base, which is just the number 1. So we have e to the x, and then you get to input the value 5, so your answer is e to the x. Number 22, it says find the second derivative of, in part A, we're going to rewrite the second derivative notation, but you have to find the first derivative first. So the first derivative would be 14 multiplied to the front and then subtract 1, minus multiply to the front and then subtract 1, and then multiply to the front and then subtract 1. The second derivative is going to be d squared y over dx squared. And again, it's on the very front page of your notes. There are different notations for the second derivative with respect to x, which is exactly what we're doing. We're taking the derivative of x. So we've got 13 times the 14, which is 182 x, and then subtract 1, we get 12, minus 12 times 11, 132. X to the power of subtract 1, you get 10, and then you've got minus 60, x subtract 1 to the 4th. So we've got second derivative notation. You have to take the first derivative, find the first derivative first. For part B, we're going to change y into 2x to the power of 1/2 because you need an exponent in order to subtract 1. So my first derivative, we can use y prime. It's a different type of notation. 1/2 times 2 is 1. We don't have to put it. X, and when we subtract 1, think about subtracting 2 over 2, so we get negative 1 over 2. The second derivative, we can put y double prime, multiply to the front, x, and then subtract 2 over 2, so we get negative 3 over 2. Again, you can leave your answer like that unless you're asked for a multiple choice question. Then you would be required to know that it's negative 1 over 2. And then this would be the square root of x cubed. Again, above number, below number, so you've got the square root of x cubed. For part C, we've got to find our first derivative before we find the second derivative. When we take the second derivative here, we're about to take the derivative of a constant, and anytime that you take the derivative of a constant, you have 0. So your final answer is 0. For this next question, it says, find the equation of the tangent line to the function at the given value. Now, in chapter 2, at the very end of chapter 2, we were finding the equation of tangent lines, except that we didn't have the shortcut that we have now. So we're still going to use y minus y1 equals times x minus x1, except for now, you get to actually take a derivative and then evaluate it at whatever x is. So for this problem, we've got the function called y, and it's a quartic, and we're going to find the equation of the line tangent to the function at x equals 2. We don't have y, so we can go ahead and figure out what y is by inputting the 2. So we've got 2 to the 4th plus 3 times 8 plus 4 minus 2 plus 1, which gets us to 43. After that, we're going to go ahead and find the derivative. dy over dx equals, so we've got 4x cubed plus 9x squared plus 2x minus 1. And then we're going to evaluate the derivative. So check out the notation we're using. We've got the derivative, and we're going to evaluate it at x equals 2. So we've got this type of notation going on. So we're going to go ahead and plug in the 2. So we've got 2 cubed, 8 times 2, plus 9 times 4, plus 2 times 2 minus 1. And from there, we get 71. So big numbers, but we can go ahead and write down the equation of the tangent line. So we've got y minus 43 equals our slope times x minus 2 as our final answer. So after this, these are just kind of bonus questions, more in-depth questions. Number 24, we're going to find the equation of the line tangent to the curve at x equals 2. So another equation of line tangent to the curve versus part B, where it says a line normal. So just to go over this really quickly, tangent just means that you're doing everything as usual. So we've got our regular slope. When you see the word normal, any sort of normal line, we're talking about a perpendicular slope. So that would be the opposite reciprocal. So for number 24, you can start by figuring out what y would be. So we've got f of 2, which would be 4 times 8 minus 6 minus 1, which gets us to 25. After that, we're going to go ahead and find the derivative using the shortcut. So we've got 4 times 3, subtract 1. The derivative of negative 3x is just 3. And then we're going to go ahead and evaluate it at 2 to find the slope. So we've got 12 times 4 minus 3, 45. So we know that the slope is 45, which, I mean, at this point, you should know that the answer is going to be C because that's the only one when we have y equals mx plus b. This format, the slope would be 45. So we know that that's going to be our answer. Just to double check, you should be starting with point slope, y minus y1 equals m times x minus x1. And then when you go ahead and move everything around, you get y equals 45x. And then you've got negative 90 plus 25, which is going to be negative 65. So that's how it ends up being letter C. Now, the equation of line normal would just mean that you are simply taking your slope of the original. So we've got the slope of the original, and we're going to take the opposite and then reciprocal. For number 25, the derivative of the square root of x minus 1 over x times the cube root of x. So first of all, everything needs to be changed into an exponent. So we've got x to the power of 1/2 minus, and then check this out. Right here, x is to the power of 1 for the first one, and then it's x to the power of 1/3. If I wanted to combine my my x's into a singular base, you need to add the exponents. So it's really 3 over 3 plus 1 over 3, which gets me 4 over 3. And then keep in mind that it's in the denominator. So to bring it up to the numerator, you're going to make the exponent negative so that you can actually find its derivative. So therefore, the derivative would be, so we could say dy over dx equals, take the exponent, multiply to the front, and then subtract 1. When you subtract 1, subtract 2 over 2 to get negative 1 over 2. So we've got 1/2 x to the power of negative 1/2. So that eliminates d and e. From there, we're going to go ahead and take the derivative of the next one. So we've got a negative times a negative, which is positive x, and then we're going to subtract 3 over 3 because we're really subtracting 1. So subtract 3 over 3, and we get negative 7 over 3. So our answer is letter choice B. 26 is an awesome question. It says find the point of on the graph of y equals the square root of x between 1, 1, and 9, 3, at which the tangent line to the graph has the same slope. So same means equal, same slope as a line through 1, 1, and 9, 3. So essentially, we're looking for the point at which the tangent line, which changes, but it's the exact same as the slope as the line through 1, 1, 9, 3. So we can go ahead and do y2 minus y1 over x2 minus x1. That's going to be the slope of the line. So I'm looking for where is the tangent line, where does the tangent line have a slope of 1/4? So to find that answer, we can go ahead and find the derivative. So we've got y prime equals 1/2 x to the power of negative 1/2. And then from there, I'm going to set them equal to each other because this 1/4 is supposed to be equal to 1 over 2 square root x. And you're looking for what x can be. Now you can go ahead and cross multiply and go through that whole solving process. Or just think about what number can I plug into x so that the denominators are equal. And then the only thing that you can plug into x would be 4. The square root of 4 is 2. 2 times 2 is 4. There we go. The denominators are equivalent to each other. So at this point, we should know that the answer is D. However, in order to figure out what the y is, you just have to plug it back into the original. So you've got y equals the square root of 4, which is 2. And that's how we get letter D. Number 27, we've got if g of x equals the cube root of x minus 1 and f is the inverse of g, you just need to know what it means to be an inverse. To be an inverse, you swap the x and the y, and then you solve for the new y. So you've got x cubed plus 1 is y. So really, f is x cubed plus 1, and then you just have to take the derivative of that. So f prime of x would be 3x squared, letter A. On this next page, we get into the really important last thing, and that is going to be position, velocity, and acceleration. So as we go through derivatives and differentiation, which means it's the process of taking a derivative, as we go through differentiation, you're going to see particles moving or things happening given position, velocity, and acceleration. It's in this particular order. We start with position. When I take the derivative of position, we get velocity. And then when we take the derivative of velocity, I get acceleration. You have to memorize this order. Please keep in mind that differentiation is talking about slope, which is the rate of change. And when we take a derivative, that's the instantaneous rate of change. Velocity, we wrote down on the first page of chapter 2. When we take the absolute value of velocity, that would be speed. Speed is the absolute value of velocity. Now, in number 28, we've got an object moving along a straight line. We're starting with position. I want to know at the instant when the acceleration becomes 0. So basically that's saying when a of t equals 0, the velocity of the object is approximately what number? So in order to start with position, to get to acceleration, to set it equal to 0, to find the velocity, we need to take a derivative. So from position, we get to velocity. So we have 4t cubed plus 3t minus 60t plus 88. Then from there, we have to find acceleration. So we have 12t squared plus 6t minus 60, and then 88 turns into nothing when we take a derivative. From there, you're going to go ahead and do exactly what we said earlier, set it equal to 0, factor it. You have to factor the long way. Set t equal to 0, both of them separately. So you get t equals negative 5/2 and t equals 2. Since time cannot be negative, you're going to have to only choose the time being 2, plug it back into the original right here, and then you get 12. To end with numbers 29 and 30, you, in order to go from velocity to acceleration, need to take the derivative first. So find velocity's derivative and then find acceleration by taking the derivative of velocity. From there, you're inputting the values. So make sure that you don't input the values first, otherwise you'd be taking the derivative of 20, which is 0, which is not true. You cannot do that. And then in number 30, anytime that you're talking about initial anything, initials before anything started, so time is 0. So you're going to find the velocity function by taking the derivative, plug in 0, you get 4, take the derivative of acceleration, velocity to get acceleration, plug in the 2 and you get 34.